Okay, we are now recording. Packaging Python projects. This tutorial walks you through how to package a simple Python project. It will show you how to add the necessary files and structure to create the package, how to build the package, and how to upload it to the Python package index, PyPI. Tip: if you have trouble running the commands in this tutorial, please copy the command and its output, and then open an issue on the packaging problem repository on GitHub. We'll do our best to help you. Some of the commands require a newer version of pip, so start by making sure you have the latest version of pip installed. So where am I? My term. So let's get away from my cool lib. Let's make our PyPI, cd PyPI. A simple, so Python 3. What is my Python 3 at this point? User local bin Python 3, sure. I wonder if that's a homebrew installation or a macOS installation. Either way, it works for me. Python 3-m pip install upgrade pip. Requirement already satisfied. Pip. Taking its sweet time. Meanwhile, my music is quiet. Where is my music? What a thrilling tutorial this will be. Where is my music? There it goes. Okay, this tutorial uses a simple project named example package your username here. If your username is me, then the package would be example package me. This ensures that you have a unique package name that doesn't conflict with packages uploaded by other people following this tutorial. We recommend following this tutorial as is, using this project before packaging your own project. Well, I don't really have a project to package, but let's follow this tutorial. Why not? Create the following file structure locally. So, you know what, let's split this screen so I can look at both things at once. Make dir packaging tutorial. Spelling is hard, folks. Make dir packaging /src packaging tutorial /src example package Erikodes. And then touch packaging tutorial source example package __init__py. And let's do vim, let's cd into packaging tutorial, and let's vim source example package Erikodes example.py def say hello print hello example. Sure. Okay. The directory containing the Python files should match the project name. This simplifies the configuration and is more obvious to users who install the package. Init.py is required to import the directory as a package and should be empty. Example.py is an example of a module within the package that could contain the logic, functions, classes, constants, etc. of your package. Open that file and enter the following content: def add one number, return number plus 1. Sure. We'll do it that way. Def add one of number, return number plus 1. If you are unfamiliar with Python's modules and import packages, take a few moments to read over the Python documentation for modules, for packages and modules. Packages are a way of structuring Python's module namespace using dotted module names. For example, the module AW designates the submodule named B in a package named A. Just like the use of modules saves the authors of different modules from having to worry about each other's global variable names, the use of dotted module names saves the authors of multi-module packages like NumPy or Pillow from having to worry about each other's module names. Okay, so NumPy, you could have NumPy.thing and Pillow.thing, and it would work out okay. Meanwhile, we've got modules that import packages. Module, the basic unit of code reusability in Python, existing in one of two types: pure module or extension module. And import package, a Python module which can contain other modules or recursively other packages. An import package is more referred to with a single word package, but this guide will use the expanded term when more clarity is needed to prevent confusion with a distribution package, which is also commonly called a package. So what's a distribution package? A versioned archive file that contains Python packages, modules, and other resource files that are used to distribute a release. This is getting pedantic, I'm afraid. Let's just go bravely forward with the... We will now add files that are used to prepare the project for distribution. When you're done, the project structure will look like this: license pyproject.toml, readme.md, source, tests. Creating pyproject.toml. Okay, we'll just make, let's see, we're in packaging tutorial, so mkdir tests. We'll just make that empty. Pyproject.toml tells front-end build tools like pip and build. What is build? Packaging.python.org. The latest key projects build. I know what pip is. Waiting for this to load. Build is a PEP 517 compatible Python package builder. It provides a CLI to build packages as well as a Python API. Okay, fair enough. To create distribution packages. I actually already clicked on that one, but let's click on it again for review, because review is good. A versioned archive distribution package, a versioned archive file that contains Python packages, modules, and other resource files that are used to distribute a release. A snapshot of a project at a particular type and time denoted by a Fusion modifier. Project, a library, framework, script, plugin, application, or collection of data and other resources, or some combination thereof that is intended to be packaged into a distribution. Okay. Getting back to PyProject.toml. PyProject.toml tells front-end build tools like pip and build what back-end tool to use to create distribution packages for your project. You can choose from a number of backends. The tutorial uses Hatchling by default, but it will work identically with setup tools, Flit, PDM, and others that support the project table for metadata. Huh. Note, some build backends are part of larger tools that provide a command line interface with additional features like project initialization and version management, as well as building, uploading, and installing packages. This tutorial uses single-purpose tools that work independently. Open PyProject.toml and enter one of these build system tables. Huh, interesting that Hatchling doesn't come with numbers in this example. Okay, vim PyProject. You know what? It looks like they've already touch license touch readme.md. Okay, vim touch PyProject.toml. Okay, vim PyProject.toml. Is there a copy button here? Nice. Requires is a list of packages that are needed to build your package. You don't need to install them. Build front ends like pip will install them automatically in a temporary isolated virtual environment for use during the build process. Oh. Build backend is the name of the Python object that front ends will use to perform the build. Hatchling.build. Configuring metadata. Open PyProject.toml. Okay, going back to PyProject.toml. Insert, paste all that. Project name, example project, Erikodes, authors, name, Erikodes, Erikodes, email, Erikodes2 at gmail.com. Hopefully I don't regret revealing that email, but it's kind of a fairly obvious one, given my username. readme requires Python greater than or equal to 3.7 classifiers. Programming language Python 3, license OSI approved, MIT license, operating system OS independent, right, because it's Python. Project URLs, homepage. I guess I can leave their URLs in there for now. Okay, name is the distribution of your package. This can be any name as long as it only contains letters, numbers, dot, underscore, and dash. It must not already be taken on PyPI. Be sure to update this with your username for this tutorial, as this ensures you won't try to upload a package with the same name as one which already exists. Right, okay. Version is the package version. See the version specifier specification. That's a mouthful. Version numbering requirements and semantics for specifying comparisons between versions are defined in PEP 40. The version specifiers in this section in this PEP supersedes the version specifiers section in PEP 345. Ooh, I'm getting tired. There's not a lot on that page. I guess I'd have to go to PEP 440. This is very technical. Not going to get into that right now. Some build backends allow it to be specified in other ways, such as from a file or a git tag. Authors is used to identify the author of the package. You must specify a name and an email for each author. You can also list maintainers in the same format. Description is a short one-sentence summary of the package. README is a path to a file containing a detailed description of the package. This is shown on the package detail page on PyPI. In this case, the description is loaded from the readme.md, which is a common pattern. There is also a more advanced table form described in the project metadata specification. That's okay. Requires Python gives the Python version supported by your project. Installers like pip will look back through older versions of packages until it finds one that has a matching Python version. Classifiers gives the index and pip some additional metadata about your package. In this case, the package is only compatible with Python 3, is licensed under the MIT license, and is OAuth independent. You should always include at least which versions of Python your package works on, which license your package is available under, and which operating systems your package will work on. For a complete list of classifiers, see pypi.org/classifiers. URLs lets you list any number of extra links to show on PyPI. Generally, this could be the source, documentation, issue trackers, etc. See the project metadata specification for details on these and other fields that can be defined in the project table. Other common fields are keywords to improve discoverability and the dependencies that are required to install your package. Declaring project metadata. That doesn't look very interesting. Creating readme Okay. Let's right quit here. Vim readme.md, paste all that. You can customize. This is a simple example project. You can use Markdown. See, I'm not gonna worry about. Well, I will. Example package Erikodes. I'll give it that much of a distinguishing stuff. It's important for every package upload to the Python package index to include a license. This tells you to install your package the terms under which they can use your package. For help picking a license, see chooselicense.com. Once you have chosen a license, open license and enter the license heads. For example, if you had chosen the MIT license, I do choose the MIT license. Vim license, paste, right quit, cool. Most build backends automatically include license files and packages. See your backend's documentation for more details, including other files. The files listed above will automatically be included in your source distribution. If you want to include additional files, see the documentation for your build backend. Generating distribution archives. The next step is to generate distribution packages for your package. These are archives that are uploaded to the Python package index and can be installed by pip. Make sure you have the latest version of PyPA's build installed. What is PyPA? PyPI is the packaging index. What's PyPA? Packaging authority. Cool. Learn something new every stream. Python 3-m pip install upgrade build. Wonder if I should be using a virtual environment for this. So far, I'm not doing anything wild, so I think it's okay. My poor computer is working so hard. Oh, we've long since got to the end of the 30 minutes here, but I'm kind of on a roll, so let's just keep going. Okay, that's all installed. Now run this command from the same directory where pyproject.toml is located, just to check. Yes, we have pyproject.toml, Python 3-m build. Creating venv isolated environment. Installing packages in isolated environment, hatchling. This command should output a lot of text, and once completed should generate 2 files in the dist directory. Successfully built example package Erikodes 0.0.1.tar.gz and example package Erikodes 0.0.1 pi none any.whl. And it's all underlined for me, which is kind of cool, I think. The tar.gz file is a source distribution, whereas the .wheel is a built distribution. Newer pip versions preferably install built distributions, but will fall back to source distributions if needed. You should always upload a source distribution and provide built distributions for the platforms your project is compatible with. In this case, our example package is compatible with Python on any platform, so only one built distribution is needed. Uploading the distribution archives. Finally, it's time to upload your package to the Python package index. The first thing you'll need to do is register an account on test.py, which is a separate instance of the package intended for testing and experimentation. It's great for things like this tutorial, which we don't necessarily want to upload to the real index. What if I do want to upload to the real index? Anyway. To register an account, go to https test.pypi.org/account/register and complete the steps on that page. You will also need to verify your email address before you're able to upload any packages. For more details, still using test.py. Okay, I'll follow their instructions for this one. I want to use a strong password, but I don't want to show it on screen. So pardon me while I move off screen for a second. Okay. Now you can see again. Create account. Waiting for api.pwnedpasswords.com. What? I guess it wants to make sure I didn't use a pwned password. $400 bad CSRF token. Access is denied. The server cannot verify that your cross-request forgery token belongs to your login session. Either you supplied the wrong cross-site request forgery token or your session no longer exists. This may be due to session timeout or because browser is not supplying the credentials required, as can happen when the browser has cookies turned off. Check CSRF token. Weird. It's just, I don't want to resubmit the form. Let's try going back to here. I don't know whether it got me, so let's get a new window and bring it over here. Someone, perhaps you, has added the email address erikodes@gmail.com to their PyPy account. If you wish to proceed with this out, click the link to verify your email address. Okay. Let's do that off screen so I don't show you the secret token. Okay. You're using test.py, that's right. Okay. To securely upload your project, you'll need a PyPI API token. Create one at test.py.org manage API tokens. setting the scope to entire account. Don't close the page until you have copied and saved the token. You won't see that token again. Let's see, I maybe don't want to be showing this right now. Add API token, token name, my example token, permission, upload packages, scope, entire account, all projects. For all of your current and future projects, good to know. Copy token. Okay, I have copied the token off screen. Let's go over to text edit, leave it over there. Because it didn't copy it. Now it copied it. Copy it now. Using this token, set your username to token. Set your password to match the token value, including the PyPI prefix. For example, if you're using Twine to upload your project, set. Okay, I think this will tell me things about that as I go through it. Don't close the page until you have copied and saved the token. You won't see that token again. Now that you're registered, you can use Twine to upload the distribution package. You'll need to install Twine. Python 3-m pip install upgrade Twine. Okay. Now, set your home/dot. So I'm gonna open a new window. Again, I'm gonna be off screen because I don't want to show you my super secret my example token. Bim home/dot pypirc. You know what? I can show you until I actually need to put the thing in. So here goes. Vim dot pypirc like this. Test pypi username equals underscore token and password equals pypi dash whatever. And then I'm gonna go off screen to put in my real thing. Okay. You will be prompted for a username and password. I think I won't be prompted for a username and password because I've put it into my configuration file, which we were just looking at. So Python 3-m twine upload repository test ppi dist/star. And let's just ls and ls dist. Cool. Yeah, Python 3-m twine upload repository test pypi dist/star. Boom, let's go. After the command completes, you should see output similar to this. It didn't prompt me for my username and password because I had written it to a local configuration file. Still working? Note, this example uses / / index URL flag to specify test PyPI instead of live PyPI. Additionally, it specifies no deps. Since test PyPI doesn't have the same packages as the live PyPI, it's possible that attempting to install dependencies may fail or install something unexpected. While our example doesn't have any dependencies, it's good practice to avoid installing dependencies when using test PyPI. That makes sense. You can test that it was installed correctly by importing the package. Make sure you're still in your virtual environment. Then run Python and import the package. Okay, there it goes. Hey, we can view it on the interwebs. Pip install -I test example package Erikodes == 0.0.1. Let's go back here. Oops. You can use pip to install your package and verify it. We'll create a virtual environment. Which virtual environment directions are they going to give me? I know. Well, anyway, I know what it's going to be. It's going to be Python 3 hyphen what? Which v, right? Yeah. Okay. Python 3 -mv nv. And while I'm at it, I want to go into here and have a to do that text. What's the difference between VNV and virtual env? Okay. Now, I'm going to double check the instructions. Source VNV bin activate. Okay. And then copy this. Python 3 -m pip install index URL test.pypi.org/simple no deps example package Erikodes. Now we do Python 3 and collecting example package Erikodes from example. Is it gonna have autocomplete? No. From example package Erikodes import example. Example add 1 of 2. Example add 1 of 2. 3. Congratulations, you've packaged and distributed a Python project. Yay, cake. Keep in mind that this tutorial showed you how to upload your package to test PyPI, which isn't a permanent storage. The test system occasionally deletes packages and accounts. It's best to use testPI for testing and experiments like this tutorial. When you are ready to upload a real package to the Python package index, you can do much the same as you did to this tutorial, but with these important differences. Choose a memorable and unique name for your package. You don't have to append your username to it as you did in this tutorial, but you can't use an existing name. Register an account at pypi.org. Note that these are two separate servers and the login details from the test server are not shared with the main server. Use twine upload dist/star to upload your package and enter your credentials for the account you registered on the real PyPI. Now that you're uploading the package in production, you don't need to specify -- repository. The package will upload to pypi.org by default. Install your package from the real PyPI using python 3-m pip install your package. Oh man, it would be so cool to put my cool package on the real PyPI. At this point, if you want to read more on packaging Python libraries, here's some things you can do. Consider packaging tools that provide a single command line interface for project management and packaging, such as Hatch, Flit, PDM, and Poetry. Read PEP 517 and 518 for background details on build tool configuration. Read about packaging binary extensions. Well, in the next episode, I think we're going to learn about Hatch. But for now, let's stop the recording on this video and return to what am I saying?